Today, we're talking about MCP server serverless on Lambda. Good morning, good afternoon, everywhere, where you are on this planet. Thank you for downloading the AWS Developers Podcast. We are available every Friday morning, European time, in all good podcast applications, YouTube, Amazon Music, Apple, and many others. If it is a good podcast application, there is a good chance you will find the AWS Developers Podcast. Today, we're talking about MCP server serverless on Lambda with my partner in crime, Tiffany. Thank you for being here.
Hi, everyone.
And our solution architect for the startup groups, one of the solution architects from the startup group, Alexis Philippard. Thank you for being here.
Thank you for having me.
So what is MCP?
As I like to see it, it's kind of a toolbox that you can expose to an AI system that supports MCP, so that they can choose which tool to use from that toolbox in order to perform a specific task. And specifically, MCP does it by imposing some sort of standardization, so that any compliant AI system could use your MCP server if deployed.
Any agent, any desktop tool, any command line tool that talks MCP protocol can invoke an MCP server. You have practical use cases where you are using MCP for?
Yeah, many actually. It was really interesting to test different things when the MCP protocol was out. So I have one use case which I use it as a demo with a AI game master doing like Dungeons and Dragons or like and so I used the MCP protocol to standardize the way my AI game master would use different tools to play a game with me.
That's cool.
Yeah, but there are other instances, I guess.
Yeah, on my end, it started with a more personal story where my wife is very often asking me to do a lot of things like to-do lists, reminders, etc. And the idea was to say, okay, if she could just do it from cloud, let's say, from cloud desktop or from the application on her phone, she could, for example, record herself, and there would be an MCP server called Alexis, myself, and basically the recording would be sent through the, or at least the transcript would be sent through the MCP server, and then I could do whatever I want with it, and basically I could classify it and then create my own personal to-do list and agenda that my wife is controlling from within cloud directly. So that was the first idea I came up.
It's funny because I start with a personal thing as well. I love to start music with Alexa, not Alexis. Mm-hmm. And I thought, it would be great if I can create a playlist based on the current song playing, keep the same mood or the same rhythm, and add that to the queue of my connected speakers as well. So I create MCP tools to generate playlists and to add that to my Sonos system, so the sound system at home. AWS has tons of MCP servers as well to connect to your AWS account. You can analyze cost, you can analyze CloudWatch logs, so you can interact in natural language with your AWS bill or your AWS account. I don't know if you try these.
I tried a few of them with Amazon Q Developer. So Amazon
as a client.
Yeah, so Amazon Q Developer supports at least local MCP servers, which are most of the ones that are currently out there from AWS. And basically, it offers great capabilities to your coding assistant. For example, I love serverless technologies. That's also why I deployed an MCP server on Lambda. But AWS has exposed one server to one MCP server to work with serverless technologies, and that helps a lot with developing those those applications, serverless applications with Amazon Q. Things like helping you with AWS SAM deployments, looking at the logs, understanding why something is failing on your Lambda function, analyzing those logs, and be able to adapt and correct the code accordingly. So that has been very useful.
So at the core of the technology, an MCP server, just a piece of code. I just want everybody to picture that, to understand that receive JSON request and respond with JSON response. But you mentioned something interesting. There is local MCP server and remote MCP server. So what's the difference? Okay, so, one is local, the other is remote, but more technically.
First of all, I think that it's important to mention that with MCP you have what we call clients, which are, for example, your coding
any
assistants.
Piece of code.
It can be Cloud, it can be any other client that supports MCP. Then you have your MCP server, and this MCP server can be a local server, so running on standard I/O. Okay.
So like the pipe on Linux, I can pipe instruction in and receive output on the standard.
And that's what most MCP servers that you have, at least up to date, we've seen out there, are doing. And basically they are allowing you to, for example, if you have a coding assistant that is running locally on your laptop, it connects to a local MCP server that can potentially make a call to something that sits remotely, right? Now, the second possibility is to have a remote MCP server where your MCP client is directly performing a request over HTTP.
Just like we are doing since 25 years. It's a REST API call.
Basically, it's an API wrapped around in some sort of protocol.
Mm-hmm. And you're right. Most of the tools that we see today, or the MCP server that we see today, are local ones. Don't run a known MCP server on your local laptop. You're running code that is downloaded from somewhere else. So the best advice is probably to protect them inside Docker, for example, to limit what they can do, or to deploy them on the server. But then there is some additional challenge to deploy them on the server. One of the things I like in the specification is that it just specified the JSON in and out. It doesn't specify how the JSON gets there. And that's why it works both with standard input and output and HTTP. But what are the specifics for HTTP?
Can you reframe exactly the question? What you mean by what are the specifics?
I'm a developer. I have a tool. It's working on std.io. I want to deploy that on Lambda. What should I do?
So, first of all, you should go and look at the MCP specifications to make sure that you are following the latest specifications. But with the streamable HTTP transport protocol that is in the specification, what you need to have is one endpoint that can have three methods. So the post, get, and delete.
So post, get, and delete. Okay.
Mm-hmm. Post is whenever you want to, let's say, list available tools or invoke a tool.
So an MCP server might have multiple tools. I can get check.
So the first thing that an MCP client would do is list all available tools, right? Then it would return a response which would include description of every tool, when to use them, what are the required input parameters, etc.
What is the granularity for a tool? In my demo, I have for my music system, I have play, it's a tool, pause, it's a tool, stop, it's a tool. Is it the right granularity, or maybe a tool might have multiple functions as well, operation?
I would say, personally, it depends on what you want. It's like always, it depends, but it really depends on the business use case that you, or use case, not always a business one, but on the use case that you're trying to implement. I think the important bit is to still be very clear in when to use a specific tool, so that the underlying LLM can understand
what are the operations
when it's relevant.
When you say be very clear on when to use it, it's about the description of the tool.
Description of the tool, which is the responsibility of the MCP server developer.
And just to clarify, for people that might not know what MCP is exactly, in this protocol, you do specify in the description of each of the tools what they're for, and you make this description in natural language. So your client reads all of those descriptions and make the decision at which tools it's using.
In natural language. That's the magical part of it.
Yes.
And that's valid for the tool, but also for all the the
Operation.
arguments
Yeah.
And the
that you
parameter.
are, that you need to pass to the tool. For example, in the blog post that I wrote, I have created an MCP server for fitness-related calculations, and one of them is to calculate your body mass index, and for that you need your weight and your height, and it's very important to make sure that the weight can be passed in pounds, in kilos, in everything. This is something that you would specify in your description, saying, okay, the weight is
In
something that
kilogram.
you express in kg, so that when the LLM decides to use that tool, it knows, okay, even if the user said, okay, I weigh, I don't know in pounds, how much would I do? But basically, I give my weight in pounds. It could decide to do the conversion and actually input the right weight in kg.
Oh, so you mean in your application you don't have a fixed you don't have a unit. The LLM.
I would trust the LLM. I would trust the LLM to do the conversion.
Okay.
In my example, is that a good way of doing it? Maybe it might be more robust to say, okay, what's the unit for the weight and what's the unit for the height,
and to add a tool to make the conversion.
Handle that in a deterministic way in my MCP server and in the actual tool code.
That's interesting.
So we talk about the first operation, which is to list all the tools. Mm-hmm. So the MCP code will return a list of operations that are available and a description of these operations and a description of the argument. That was the post verb that we need to implement, correct? Or the get?
The post can also allow you to invoke a tool, right?
Okay.
And so
that's the second step. Once the tools are discovered, we can invoke them.
You can invoke them. And then, really, the idea is to based on the tool that has been chosen, the arguments, a specific piece of code that you, as an MCP server developer, have created will execute. Then you will have an output that will be returned back to
the
cloud,
caller,
to whatever. And then, based on that information, the LLM will decide to format the answer in a human-readable.
And the response is a JSON response.
The JSON is
and
also
it's the responsibility of the LLM to
JSON RPC 2.0.
Okay. And you said there is a delete verb, which is supported as well?
There's a get and a delete.
A get and a delete.
The delete is whenever you decide to have a stateful remote MCP server where you maybe you want to persist the state across tool calls, that might be necessary in some cases. The delete verb really is useful for saying, okay, I'm explicitly closing this session.
Okay.
And then you have the get verb that is being used if you want to enable server sent events. So basically, you might want your server. You might want to allow your server to decide to send event back to your client, and specifically one of the features of MCP would use that technology if you want, which is called sampling. So sampling with MCP would allow your server to decide to actually leverage the LLM that's sitting in your client to run something and then get a result back. So basically, your server would use your client as a tool if you want.
Mm-hmm. So as a developer, I need to implement these endpoint and then to deploy that somewhere in the cloud. I forgot something.
No, it's true. But for the get and the delete endpoint, those are optional in some sense.
Okay.
So you can decide not to implement them and return a specific status code to say, okay, it's not implemented. Because in some cases you might not want or need a stateful solution, and you might not want or need a server sent event.
So I take my favorite web framework, Express.js if it is TypeScript, Flask if it is Python, Hummingbird if it is Swift, and I implement this endpoint, and then I deploy that to the cloud. So I guess there I have all the deployment options that our listeners knows already, EC2, ECS, EKS,
Exactly.
and many others. And with load balancer, we can have all the complexity that we know already about web services.
In a nutshell, what you are trying to do is to deploy an API endpoint.
Mm-hmm.
That's
like we are doing since 25 years.
and then what happens on your API endpoint needs to be MCP compliant.
Mm-hmm.
That's as simple as
it's just the JSON that goes on the wire that makes it an MCP. So what is specific for Lambda then?
So with Lambda, as Lambda and API gateway, there are some. I mean, it has some strengths and some limitations. The first biggest limitation that we will imagine is server-sent events. So if you want to support server-sent events, Lambda and API gateway specifically would not be the best choice, because API gateway, you have a timeout around 29 seconds or 30 seconds. Meaning that if you want to have a persistent connection, it would drop after 29 seconds.
So that's the use case where the server
decides
send
to send
a stream of event. Like I'm sending my CloudWatch logs back to the client, or I don't know, temperature, sensor data. And API gateway close the connection after
even if your Lambda function
seconds.
can run for 15 minutes, API gateway has a lower timeout.
But even in terms of cost, that wouldn't make sense to implement that on Lambda, because your Lambda will run all the time. That will cost you a lot of money compared to
that's what serverless is all about. Per second or per millisecond, it costs more to run the same compute than, let's say, on an EC2 instance. But the thing is, with serverless, you're not expected to run all the time.
Mm-hmm.
So that's where using a stateless MCP server that is just supporting raw HTTP that allow you to perform a tool call and get an immediate response, that's a very good use case, because you don't need to manage the underlying infrastructure. You pay only per request and obviously per the length of your tool invocation, but generally that can be very fast. And if you have a very long running tool, you would not use Lambda, obviously. So really the idea is that I would say in more than 90 to 95% of the cases, the setup, API gateway plus Lambda, is actually giving you the value or business value that you're expecting from an MCP server.
Yeah, the long-running case or the streamable case are probably not the majority of the use case to use MCP server. So Lambda plus API gateway, perfect fit for short-term invocation. You invoke the tool, it gives you an answer, and that's it.
But so sometimes you have multiple tools that you are being called. Would you recommend that for Lambda functions then?
Can you give me an example of?
But I was thinking of the demo I was building. But so, for example, if my client needs, to run a tool and then to wait for the answer of the tool to take another decision, to go on and do another action. If you have multiple tools that are quick in the sense of each of those tools run quickly. But if you have many, and sometimes you can't really predict how many calls there are going to be, so you can't really predict how long this chain is going to be before the response gets back to the client. One
tool invocation would, under the hood, invoke many different things?
Yeah. Because that happens to in the case of my AI Game Master, that happens sometimes. That my AI Game Master needs different informations to be able to make a decision as to where the game should go further down the line. So, but that I cannot predict how long the conversation between my AI Game Master and his tools are going to be. For example, he has a tool that can roll a dice, and then the result of the dice roll will impact the next decision, which is I don't know, creating another character that comes up in the story, and then this new character needs several dice rolls to, I don't know, like define some of these characteristics and stuff. But so I do use Lambda functions for this. And I never really asked myself the question, is this the right fit for my application? Because each of those calls are pretty short. But actually, listening to you now, I realized that probably not.
So in a sense, if we take that back into the let's say the realm of an MCP, your AI master, game master, is your MCP client.
Yes, yeah.
And it has a set of tools or capabilities.
Yeah.
Rolling dice, and I'm not
creating characters.
Creating characters. I'm not I used to play those games when I was younger. I loved them, but been long. But yeah, every capability can be considered as a tool, and every tool runs very fast. And you, indeed, as you said, you don't know how long they will run, but every invocation to run a dice is one tool call. So actually, it's a good fit.
Yeah, for each. Okay. Yeah. If the run for one.
Yes. Yeah. If you were telling me that your tool is actually maybe you have another AI system that is invoking, calling your AI master as a tool, and that runs for long, then your AI master, I wouldn't put it in a Lambda function, because that indeed, as you said, the combination of everything can make it run for very long, and for probably longer than 29 seconds in some cases.
No, I get what you mean. And actually, my master, AI game master, calls other agents that do have access to other tools.
Yeah.
So this is where it can get pretty complicated really quickly with those architectures.
What is a tool? What is an agent? Where is the boundary? When an agent is also a tool, when a tool is also an agent.
Yeah, exactly. So I guess for this, it's good when you call a tool that runs on a Lambda function. But if you call another agent that runs on other tools, then that's.
Yes. That's running an agent on a Lambda function that is fronted by API gateway is risky, because it would in many cases, a turn of an agent invocation would take more than maybe 29 seconds. And in many cases, you're just waiting for something to happen, which you are paying for with the Lambda function. So there, in that situation, you might think of other kind of setups.
So the good use case is short invocation, synchronous invocation, not streamable invocation. I have to implement this get endpoint, so I need to configure my API gateway.
You don't have to. You can.
That's my not get, post. Sorry,
okay.
I have to implement this post invocation on different URI, on different endpoint.
No, you only have one.
Only one, so and it's different parameter in the JSON. Then
yes, that's your body is different based on which tool you're invoking.
So what's the next step? Should I configure my API gateway to relay the post function to the Lambda? How do you do it?
So if we take it to the implementation that I did on the Lambda function, so you have an API gateway, which is your entry point. It will proxy, in my setup, I'm just proxying every request to my Lambda function. Okay. And then in my Lambda function, I have an Express JS application running.
So you're running a web server, a full web server inside the Lambda function.
So there is a small let's say adaptation layer that you need to implement. On my end, I used serverless HTTP, which will convert the request into something that the event that comes in your Lambda function
gateway,
into something that can be understood by Express. Okay? Then Express in itself, I have another file that is just agnostic to where it's running. So technically, I could say if one day else. I could just take all the files except the one that converts the API gateway request to Express. I could take all the other files and run it on Fargate. That would technically work. the idea is that when it reaches Express, I will have one. I will have my endpoint that we talked about defined there for my post request. I will then send it to a service that handles everything related to MCP. So in my situation, I use the official TypeScript SDK for MCP, which allows you to have your MCP server running and then accept, let's say, compliant MCP requests, and then handle them, proxy them to the right tool, and then invoke the tool, return the result in a compliant
JSON
format,
RPC.
JSON RPC 2.0.
And you don't have to deal with that low-level format.
No,
That's the MCP SDK.
Yes, that handles
the
that
official
for us.
one
Yes.
that handles that for you.
And then, and basically, the Express is mainly for the Express application is for performing some header validations, error handling, and also to because the MCP SDK, the TypeScript SDK, expects a request that comes from Express.
Yeah, so it makes sense.
Yeah.
Then it's the easiest. It's to encapsulate your MCP
And-
server in Express and deploy that beast.
Yeah, and
in
actually,
one shot.
it's very well documented on the GitHub repository of the official TypeScript SDK.
Oh, they even explain how to deploy to Lambda?
No, not to Lambda, but you have an example on how on how it works with Express, and then you just need to plug the additional
the
glue
tiny
layer
Lambda
to make
layer.
it work with Lambda.
And how do you deploy? I'm just curious. Are you using SAM,
used,
CDK?
CDK,
the console.
CDK. I used to be a very big fan of SAM. I'm still am, but I recently I've been playing more and more with CDK, so that's why I chose it.
It's not relevant to MCP.
It's not relevant. It's just But an important thing is always think about deploying your applications using infrastructure as code, and actually specifically with serverless, it allows you to have many versions of your same MCP server, and then be able to play around and test it.
How do you test? Of course, there is the unit test, and that's the easy thing. That's the part I understand. But if I want to test it in real life, what should I do?
Good point. Still start with unit test, because on my end, what I did was to have a set of tests just to validate compliance with the specification. So that's one thing. So at least it gives you some
guarantee that you follow the MCP protocol.
Work.
Yeah, but if you use an SDK, that's the responsibility of the SDK.
But on some of the, for example, the SDK does not tell you, for example, if you want to return a specific error code, a specific error code, or for example, for the GET request that is not being implemented, you need you need or want to return a specific response format.
Okay.
And that's that's what I implemented. But then next to that, MCP also gives you a very nice testing tool, which is the MCP inspector. So it's
what is it?
It is basically a UI in which you can test your MCP implementation.
So it's a web tool?
Yeah, it's a web page that is running locally.
Okay.
So it spin ups a web page on localhost, and then you visit it. You enter your MCP endpoint. You hit connect, and then basically,
and then it doesn't work.
And then the first thing
usually the first time.
The first time it doesn't work.
That's my experience. At least.
And then you can basically list the available tools. Then you have your list of tools. So you click on the button list available tools. You have a list of tools that you can use. You click on one of them, and you can enter the parameters, and basically it will get you the result. But obviously,
so it's a playground that simulates a client or that act as a client.
Yes,
to your MCP server.
But where no LLM is in the picture.
Just
right?
invoke
just
the tool.
Validate that it's rightly formatted and that it works. And then while testing, you can even run your setup locally if you want. So that's to avoid having to redeploy it every time if that's what you want. So that's a first step. Once that is validated, you can say, okay, now and obviously that's what everyone would like to do, is to test it with an
real
LLM,
client.
with I mean to really see it live and not just the inspector. And on my end, I think when I tested it, the one of the only supported, MCP client that supported remote MCPs was Cloud Desktop. So that's what I used to test it. So basically, it's fairly simple. You have this small toolbar that you click on. You click on Add Integration. Basically, you can give a name to your to your integration, and then you just provide the URL of your MCP endpoint, and
if it works on the playground on the MCP validation tool, I forgot the name, integration tool,
MCP inspector.
Then I guess it works on.
That's what you expect, yes.
Sure. Okay.
But at least on my end, actually, I was those cases where you are doing something and then it works and you're like, there's something wrong. It shouldn't be working from the first time, but it worked. So basically, on my end, I had this fitness calculator MCP, and I started asking questions to Claude related to my health, and it was performing the right calculations and calling my MCP server, asking me to if I allowed Claude to actually invoke this tool. It worked. A charm.
You said two things important. One is super important if you are new to MCP server and client. There are really three actors there. There is like the agent that you work with, like Cloud Desktop, like a command line tool or something like that. There is the model, which is like the brain of the operation. And there is the MCP servers with an S at the end that list all the tools. And the agent, the client, is the one that will invoke the two others. But the model is the brain, the orchestrator that will decide, to get you that answer to that question, we need first to invoke that tool, and then that tool, and then that tool. That's what you were explaining with your game example as well. And these are really three different components. The one on which we have very low level of control is the model, because we don't know always how the model will coordinate the different tools or the workflow to get the result done.
Unless you do have your own model, like that's, I mean, if you're a big company or if you have specific needs, then you can have your own model. But
and based on your experience, is the model really relevant, or you get similar result with, I don't know, Claude 4 and Llama? And
in my situation, I've just tested it with Claude, but in a nutshell, I mean, if you think of it, here Cloud Desktop is our MCP client, and indeed there's the client itself, which under the hood runs with an LLM. But you could, if you are a company that wants to create an agent that leverages MCP, you could create your MCP client and decide on the full system prompt that you're sending to the LLM, and you could be very prescriptive on how to use the tools, and and so but I mean, what I mean by that is you could adapt it to your specific use case as well. So when you think about Cloud Desktop, it's a very let's say public kind of tool. It's not very specific to a vertical, an industry. It's just something that anyone and everyone would use. So there, it's just, okay, here are the available tools that you can use to answer a random question from a user, but it will not know in which context it operates directly. Whereas if you're creating your MCP client with let's say maybe a customer facing agent, you will be very specific
about the system.
You are a client that you are basically an agent that helps customer do X, Y, and Z. And you have those tools available. Maybe only use those tools if it's really relevant. I mean, many. So it's really, it would be more about prompt engineering also in that case.
I made the exercise. I wrote my own client and switching models because with Bedrock, it's super easy. Yeah. It's one line of code change. And I don't get the same result. There are some models that are better at decomposing a complex task into smaller units and taking advantage of the tools or not. So it really, yes, you have to work on the prompt, on the system prompt, but also do a bit of experience with the different models.
And if timing is not really an issue, you could even use reasoning models that will even maybe have a better result in terms of orchestration of the different tools it wants to use.
And the other things that you said that triggers my interest is that not all clients support HTTP
remote MCP server.
MCP server. Almost all the clients today support standard I/O, so server running locally on the same machine with the security caveat that we talked about already, but just a few support remote. Because when we were preparing this episode, I asked you why you are not using Amazon Q, and you said because as of today, and I have to say we are recording this episode in July 2025, so as of today, Amazon Q CLI or in the IDE doesn't support remote HTTP server yet. What are the tools you know that support remote server? So Cloud Desktop is one of them. Did you find other? Cloud Desktop?
Cloud Code as well now. The other one,
you don't know. You never explored.
I didn't check recently, but
GitHub and
I
Copilot
didn't find many of them. Okay. But the idea is that you can always create your MCP client. There's, the SDK is there as well.
Yeah, there is a bit of work.
There's a bit of work, but it's not. From the moment you're creating an agent, let's say you're a company, you're creating an agent.
Yes.
You might as well make it MCP compliant, right?
Yeah.
You have experience with different type of clients?
I use plenty of different ones, but yeah, we mentioned Cursor or
and
others.
they support HTTP server or remote MCP servers.
Yeah,
okay. So there is a couple of choices now. It's not only Cloud Desktop.
But if we really think about if we already talk about the future, I think more and more
it's a matter of time.
Clients will support remote MCP servers because it's basically a way for businesses to expose their know-how as an API that an AI system can plug into.
Yeah, that's actually the very interesting and that's the part that has a lot of potential with MCP is specifically that remote part. Where you can connect.
So MCP can achieve what we never achieved to do with REST web services. 30 years ago, every company had to have a website to stay relevant in business. 20 years ago, everybody has to have an API, but there is no universal way to discover API, to invoke API, to authenticate with API. So it's still a very one-to-one relationship between the API client and the provider. Do you think MCP has the potential to be like a universal language to discover, to access API from vendors?
In that sense, they will be driven by, an
agents?
LLM to understand what you can do with the API. But if there's not an LLM running underneath your, MCP client, I would just use a REST API, a regular REST API. I wouldn't see any added value.
There is one added value. There is the discovery on an. You said it in the MCP server. There is a standard list operation that doesn't exist with REST.
Okay, but you have other tools that do that. For example, GraphQL
that's true.
Give you some sense of discovery as well into a specific API structure. So in that sense, it kind of exists, but yeah, potentially that could be valid as well for MCP servers.
But before we are there, there is one subject we didn't address yet.
Yeah.
It's the elephant in the room. It's security, authentication. We cannot just call a remote web service because that's it. It's a remote API without authentication. So how can we fit authentication into there?
First of all, you can.
Yes,
so you can deploy. As with a regular API, you can deploy a public-facing API. And the specification, the MCP specification, says you should implement authentication It doesn't say you must. So it means it's still it's
not
optional,
mandatory.
right?
Mm.
Obviously, in many cases, you want to have authentication, and basically the MCP. The specifications for the MCP, your remote MCP server, is basically some sort of cherry picking of practices in the OAuth 2.1 specific.
So it's based on token, JWT token that we need to inject into the HTTP header, something like that.
So basically, your client first would register to your MCP server. It would return. It would register it on your backend systems. It would return a client ID. It would then use this client ID to actually authenticate your users. Eventually, your user.
Wait.
Yeah.
Wait. I'm the user. I'm using a client which has support for remote MCP server with authentication, Cloud Desktop. I register my remote server, so I just give a URL. What's next?
So Cloud Desktop would register itself as a client to your MCP server.
How it does that? It needs to call a specific
there's
URI?
a route called a dash register, and then basically with some additional parameters, it will you will need to store information about the specific client that has registered with the redirect URLs, etc.
So it pass a redirect URL, just like in an OAuth authentication.
Yes, but the MCP protocol states that you should enable dynamic client registration. So that's what's happening there. So then you would return the client ID to Cloud. Then the MCP client should store this client ID somewhere to be able to use it when it tries to authenticate a user. When it tries to authenticate a user, we enter the regular authentication flow.
So it opens the URL that has been given back by the server. Like it says, basically your tools, your MCP server says, go and authenticate yourself or authenticate your user, the one behind the keyboard, to that URL.
Yes.
And so the client, Cloud Desktop, opens that URL, which is an authentication page on Okta, anything Cognito.
You enter your credentials,
passkey, biometric, whatever,
whatever you want. And then you enter your credentials, and you basically once the credentials have been validated, the flow ends. It returns this JSON Web Token back to your MCP client that then can use that to perform the calls to your MCP server, which are all the calls that we talked about earlier about listing the tools, invoking the tools.
So the MCP client, so Cloud Desktop, will receive from the authentication server a token, and from there, for any HTTP request sent to the MCP server, it has to inject the token in the HTTP header. And then on your side, in a Lambda function, you can inspect these HTTP headers, and you take also authorization decision at that level.
And you can you can do that as part of your Express application if you want to make it very portable. As I said earlier, for example, imagine that you want suddenly you decide that Lambda and API Gateway is not the best fit, and you need to move it to Fargate, for example. Then checking your authentication token inside your Express application might make sense. If you're good with Lambda and the API Gateway, you could even do it, for example, at the API Gateway level with a Lambda authorizer or even a GWT authorizer.
Yeah, the Lambda authorizer means it's another Lambda that will be invoked by the API Gateway just to validate the token and return a policy, either a no, either an IAM policy with permissions for that token.
And you can obviously cache also the authorization so that you are not re-invoking that Lambda function.
And I dream about a future where we can include CEDAR policies and the authorization system. in that. But at the end, my message here, it's just a JWT token, part of the HTTP header. So that's what the industry knows how to manage since 20 years.
And then the nice part of that is that you can you identify client, you identify user, and that gives you access to monetizing your MCP server, because you can know which client is using your MCP server, but also which user are using your MCP server through which client. And I mean, there you have an infinite number of possibilities of deciding how do I want to monetize my service.
If we were in a cartoon, you would see the dollar in my eyes, shlink.
Yes.
That's the future. That's the app store for MCP server.
Actually, while preparing today, I was thinking about something like an app store for MCP servers. Yes.
Yeah.
Any single developer could create something that is valuable for anyone to use as part of an.
It does make sense that this might go this way, like a marketplace or where.
And to the opposite of REST API, it's not only for developer, an MCP server. I mean, everybody, any business person can add an MCP server to their clients, to their cloud desktop. So the market is much larger. Yeah. It's not just for developers.
When I was saying developers, is developers creating the MCP server. Yeah. So you could have a one-man show that has a brilliant use case for an MCP server and monetize it as a MCP as a service, right?
And this is what we said a few minutes earlier. We can imagine most business going to propose MCP server as part of their public API.
And it's in their benefits to do this, because I think this whole MCP route goes to like the fantasy of having this Jarvis, this assistant that could do pretty much anything for us. And you can imagine something in the future, like you talking to Alexa or whatever vocal assistant you have, and they would be able to go on any website and perform actions for you. And they would be only able to do this if like all of those endpoints are open, and like all of those big companies do have servers that are MCP compliant that can talk to your Alexa on your behalf.
And I think that's also that brings, if you take it even a bit further, you can imagine some businesses not even needing to have any front end or application.
Yes.
Because basically, you could imagine having a business saying, why would I develop a front end facing piece where I have cloud that can integrate perfectly with my MCP server, and actually it can even remove friction. So meeting your users where they are and where are they? I think everyone here is using either ChatGPT, Cloud on a daily basis. So if your business is already there, what they are doing every day, I think you are way closer to your users and to creating value for them and value for the business.
And suddenly the big battle of the moment of having their own browser for OpenAI or for Perplexity to release their own browser makes a lot of sense to me, because that's the entry door for that ecosystem that we still have to build. So I hope we give you a couple of business ideas for the future, that you have a better understanding of how MCP server works, especially on Lambda in serverless, when it makes sense to deploy them on Lambda, when it doesn't make sense to deploy them on Lambda. Thank you, Tiffany.
Thank you.
Thank you, Alexis, for your very clear explanation. Thank you for having listened to the episode until the end. See you next week for another episode. But now, go build your MCP servers on Lambda, of course.